Let's talk a little bit more about the process of cooling optimization. I've already mentioned this in a number of different ways as I've been going through the slides so far, but it's important to reiterate. It's the process of making adjustments to the cooling system controls to improve energy efficiency. And again, the benefits are myriad, and what's important to you varies. It could be costs, it could be cooling capacity, could be IT equipment reliability, getting hotspots, or deferring capital expenditure. There's many business cases where improved airflow management what prevented the construction of either a new data center or a substantial remodel addition to an existing data center. And the value of the savings of deferring those massive capital expenditures can be enormous. Or even if it just means deferring the capital expenditure for buying another cooling unit. Most data centers have way more capacity than they need. It's just a question of utilizing that capacity that's already been installed more appropriately. It's an iterative process. Very rarely do you make adjustments and you're done. Adjustments to optimization need to be done incrementally and slowly to make sure that changes don't cause any problems. And as equipment changes in the room, rooms are dynamic. As the IT equipment goes or is added, load shifts and changes. The cooling units rarely are capable of making the full adjustments to realize the energy efficiency benefits that can be achieved. Most cases, some intervention is required in understanding the process in the room, understanding these fundamentals that I've shared with you, enables you to go in and make those adjustments to realize those benefits. And, you know, as I said, any significant change in a room is an indication that optimization could be done. And it's often when equipment leaves a room that optimization is potential is there. Without cooling optimization, I'm going to keep beating this home, that airflow management improvement is largely an expense. It's making those adjustments that achieve the benefits. Efficiency can't be purchased. It has to be managed, and intervention has to be done. So let's revisit again that very important concept of bypass airflow and how this works. So now in these diagrams, I've added some numbers, and these numbers represent the volumetric flow rate, or the flow rate of air. So in the United States, the unit that is most common is CFM, cubic feet per minute. These numbers are much greater. You know, a single cooling unit might have thousands of CFM, but just for comparison's sake, we'll just look at these simple numbers. And so in this room, we have a total of 10 units of air moving through the cooling units. So if you add up all the air coming out of all the openings, there will be a total of 10 units of air. And in this case, we have 6 units coming out of the supply tiles in the cold aisle, and 4 units of air coming out of unsealed openings under the cabinets, 2 in this row and 2 in this row. We have in this row of cabinets, the IT equipment consuming 2 units of airflow. And in this row of cabinets, another 2 units of airflow is consumed. So with 6 units of conditioned air delivered to this cold aisle, 4 units is sucked up and consumed by the IT equipment, leaving 2 units of conditioned air leaving the cold aisle as bypass airflow. We also have another 4 units of bypass airflow from these unsealed cable openings. So there's a total of 6 units of bypass airflow in this room. And this is very, very common, even conservative numbers for most computer rooms. Many computer rooms have much higher ratios of bypass airflow. And when you look back at the equation, it's simply the total airflow through the room, 10, minus the amount going through the IT equipment, 4, leaves you with 6 units of bypass airflow. By improving airflow management in the room and sealing the cable openings in this example, all 10 units of conditioned air is now delivered to the cold aisle. However, the IT equipment still only requires a total of 4. We still have 6 units of bypass airflow in this room. And many people would look at this diagram and say, well, all you do is you need to just put a roof on there and put doors on the aisles, and you'd block that 6 units of bypass airflow. And that's not actually the case. You would prevent the air from leaving the aisle out the top of the aisle, but you wouldn't change the amount of bypass airflow in the room. This extra 6 units of conditioned air would just be forced to flow through the IT equipment when it's not needed. It is essentially still bypass airflow. So now that we've improved the airflow through the room, we've done all the airflow management methods, blanking panels, sealed the raised floor, put doors on the ends of the aisles and baffles or a roof on top of the cabinets. We now have the ability to reduce fan speeds or turn off half the cooling units in the room and realize those benefits. We'll turn it down not all the way to 4, but to deliver 5, have a little extra conditioned air, to have a little buffer for variations in IT demand and slight positive pressure in the aisle. But now from an airflow volumetric flow rate perspective, the cooling has been optimized.